Even when we have a graph, the goal is still the same, to write an equation in the form y equals mx plus b, where m is the slope and b is the y-intercept. For this graph, we can see the y-intercept very clearly on the graph. So remember, graphically, the y-intercept is the place where the line crosses the y-axis, and we can see that that's happening right up here at 100. So we know that our b value is 100. Remember, to find the slope, we have to locate a couple nice points on the graph, and then we can use those points to calculate the slope. So one of the nice points we can use is the y-intercept, which was that 100. And then if I look down the line a ways, and I'm looking for a nice pretty point where I can clearly read a price and a number of customers without having to estimate too much. And I can see one kind of right there. And I'm not really looking at the data point that's shown, but actually the point on the line that seems to be right here at $10 and 60 customers. So now I can use a slope triangle to help me find the slope. So if I take a look, to get from the first point that I circled to the second point that I circled, I have to travel straight down. And then I also have to travel over to the right. And so all I have to figure out is what the rise is and what the run is for that slope triangle. So if I take a look at this slope triangle, it looks like I've moved down 1, 2, 3, 4 boxes. And we can see from the scale here that really every box is representing 10. So traveling down 4 boxes is actually like traveling down 40. And since it's down 40, I'm going to put a negative on that 40. And then I can look at the run. It looks like I'm moving over 1, 2, 3, 4, 5 boxes. And if I look at the horizontal scale, it looks like it's actually going up by $2 each time. Each box is $2. So if I have 1, 2, 3, 4, 5 boxes at $2 each, that makes a change of 10. So now to figure out the slope, I'll do the change in y over the change in x. You could also think of that as the rise over the run. So my rise is negative 40, and my run is positive 10, and negative 40 divided by positive 10 is negative 4. So that is my slope, or my m. So now I can write my equation, y equals negative 4x plus 100. So one more problem where we have to write the equation from a graph. So this time I think, again, I'll start with the y-intercept. I can see the y-intercept on the graph. It's right here where my line crosses the y-axis, and we can see that clearly happening here at negative 3. So my y-intercept, or my b, is negative 3. So now I'll kind of scan the line to find another nice point on the line that's easy to read, and it looks like there's a lot of them. I see one right up here, and again, there's more than just that one. So now I can draw a slope triangle. It looks like I have to travel up and then travel to the right. For this graph, the scales are pretty consistent. Each box is just counting up by ones for both of our axes. So I can just count boxes to find the rise and the run. So the rise, let's see, I went up 1, 2, 3, 4 boxes. So my rise is positive 4. And then I went over to the right 1, 2 boxes, so my run is positive 2. So remember, to find the slope, we're going to do the rise over the run. So that would be 4 over 2. 4 divided by 2 is 2. So that's my slope. I can write the equation, y equals 2x plus negative 3, or I could write y equals 2x minus 3.